Hi everyone, welcome to the video answer key for this worksheet on pH calculations for strong acid and strong bases. Now before we even get started, let's remind ourselves of what it means to be a strong acid and what it means to be a strong base. Now strong acids and strong bases, they are considered strong because they dissociate completely in water, right? So due to this characteristic, this comes about so that we can do our calculation. So the concentration of the acid would equal to the concentration of the H plus ion. And then for the base, the concentration of the base is equal to the concentration of the hydroxide ion. So let's go ahead and use these two relationships and do all our problems here. Now, number one, let's calculate the pH of a 3.49 molar solution of HBr. Now HBr is definitely a strong acid, so we know that we can use this relationship here. I'm going to go ahead and underline what I know and then just a little question mark onto what is it that I need to find out. Now since HBr is a strong acid, the concentration of the acid would equal to the concentration of the H plus ion. And why do I care about the H plus ion? Well, I need to find the pH. The pH is a negative log of the hydrogen ion. So if the concentration of HBr is 3.49, as stated here in the given, the concentration of the hydrogen ion is also 3.49 molar. So now all you're going to do to find the pH is that you plug it in. So remember that pH is negative log of H plus. So negative log of 3.49 would give me the answer of negative 0.53. 0.543, sorry. It is possible to have a negative pH. It is not a mistake. It is possible to get a negative pH because HBr is extremely strong, so your pH dips under 0 sometimes. Now just make sure that you had the correct amount of significant figure. So for a log function like this, we consider the rules for addition and multiplication for a sig fig. So here we have 1, 2, 3 significant figure. So your final answer should also have 1, 2, 3 significant figure. So go ahead and use number 1 as a model for number 2. And let's go ahead and do number 3. So here I have perchloric acid. Perchloric acid is definitely a strong acid. So this falls into, what our relationship that we set up here. All right. Well, this is very simple, and we basically kind of do the same thing over and over again. But just make sure that we are finding the correct things, or what is it that they're asking of us. So in order to find the pH, let's go ahead and state again, the concentration of perchloric acid is equal to the concentration of the hydrogen ion. And all that's equal to 0.5 molar. Now the pH is the negative log of this number, 0.35. I'm going to use my calculator here, and negative log of 0.35, and it gives me this long number. This has two significant figure, 1, 2, so I'm going to round this down to 2 significant figure, so 4.6 times 10 to the negative 1. Okay, well, this is my pH, so I'm going to go ahead and box that. And let's find my pOH. My pOH can be found using this relationship, pH plus pOH is equal to 14. So the pOH is 14 minus the pH. So the pH is this much. I'm actually going to, instead of using scientific notation, I'm going to do 0.46. This makes it easier for me to count significant figure. So 14 minus 0.46. Okay, so it's going to be 13.54. Here it's in significant figure, but if you want to just double check, you can put it back to regular number and make sure that the answer ends in the 100th place, because this number ends in the 100th place for your significant figure. So there's my pOH. Now you can use number 3 then to do number 4. It's pretty similar. Let's go ahead and do number 5. Calculate the concentration of HI needed to make a solution with a pH of 8.2. Now previously, in number 1 through 4, they give you the concentration of the acid and they ask you for the pH or the pOH. Number 5 is different because they don't give you the concentration. In fact, they ask you to find the concentration knowing the pH. So this is where we're going to go backwards with our logarithmic function. Now recall that the concentration of H plus is equal to 10 to the negative pH, right? And how do I get the concentration in H plus? Well, I have my pH here. And because this is a strong acid, the concentration of H plus is going to equal the concentration of the acid. That's how you're going to answer the question. So let's go ahead and plug this in. So 10 to the negative 8.2. So if you plug this in my calculator, it should give me this number. Let's go ahead and convert that to scientific notation. And I have 6.3 times 10 to the negative 9. Alright, we're not done. You are showing me the number for the concentration of H plus. Now I know this is also the concentration of HI, but you need to make it very clear by saying that, okay, now the concentration of HI is 6.3 times 10 to the 9. And then there is my final answer. Okay, so number 6 is just like number 5, so you can go ahead and do that. Let's do number 7. Now, number 7 is similar to basically number 1 through 4, but the only difference here is that this is a diprotic acid. Now, regardless though of it, whether being it's diprotic, remember that in our class we always assume that the acid dissociate only into one hydrogen at a time, meaning it releases one hydrogen at a time. And this is what I mean by that. When this acid dissociate, it will dissociate into H plus and HSO4 minus. So we don't care about this anion because actually this is a weak acid. So and there's a whole different set of calculation we need to do with a weak acid. So for now, for this worksheet, we are not going to care about this hydrogen or this whole acid, weak acid as a whole. Now, let's go ahead and basically follow along with what we just did from 1 through 4 and go ahead and find out the pH. I'm going to let you to do that actually on your own. Right? So it's going to be the same thing where the concentration of sulfuric acid would be equal to the concentration of the H plus. And then knowing the H plus, you can go ahead and find the pH from there. Right? It's the same process. So after all these acids, let's go ahead and do some strong bases here. Number 10. Now, number 10 asks you to calculate the pH of 0.34 molar of sodium hydroxide. Now, historically, students have been very excited to see this kind of question for either a strong acid or a strong base. Now, it's perfectly fine to just, okay, well, that's great. Let's just take the negative log of this number and then we get the answer. That works just fine for a strong acid. This is not a strong acid. This is a strong base. So make sure that when you do take the negative log of this number, you actually come out, you're actually finding the POH and not the pH. So moral of the story is that you are going to need to be very careful with what is it that's given to you. Make sure you know that this is a base, and then also make sure that you are reading what the questions ask for. If it asks for a pH of a base like this, there's an extra step we need to do. If it asks for a POH though, sure, you're just going to do the negative log of this number. Because a strong base works just like a strong acid. So let's go ahead and go through number 10 together then. Well, because the concentration of sodium hydroxide is going to equal to the concentration of the hydroxide ion, which is 0.34 molar, I can then find a POH of the solution. And it's going to be the negative log of 0.34. Now let's put this into our calculator. Negative log of 0.34. This is 2 sig fig, so the answer should be 4.7 times 10 to the negative 1. Okay, that's my POH. Now we are not done because this is only the POH, right? We need to find a pH. How are we going to find a pH? Well, remember this nice solution. Sorry, not solution, equation. pH plus POH is equal to 14. We know the POH already, so we can find the pH by simply doing 14 minus POH. And the POH, this is 0.47. And then when we put that into the calculator, we get this number. I'm going to go ahead and change this back to a regular number. 13.5347, that's to the 100th place. This is also to the 100th place. So everything significant figure wise, we are good. So that's my final answer. That's the only one I'm gonna box. Okay, I know this seems kind of intuitive, but this happens all the time. Okay, historically, students get super excited and she's gonna take the negative log of this number and they think they're done. But be careful. Make sure to read the questions. They're asking for the pH of a base, which usually doesn't go together. So make sure you read the question carefully. Now, number 11 is similar to number 10, except, take a look. There are 2 of the hydroxide ion. Now this changes our calculation a little bit. When calcium hydroxide dissociate, so here's the association reaction, it dissociates into calcium plus 2 and OH minus. But not just OH minus, it dissociates into 2 OH minus. 2 OH in the beginning, 2 OH at the end. Because of this reason, the concentration that you're going to plug in to your POH is going to be different. Now, at the beginning, calcium hydroxide has the concentration of 0.92. When it dissociates completely, that concentration is also found for each of its ions. But because there's 2 of these ions, you basically have double the amount of moles, aka the concentration. or not aka, I guess, as a result of the double amount of moles of hydroxide in the solution, as a result you get double the concentration. So because of that, this becomes 2 times 0.92, 1.84. So this is my concentration of hydroxide. Okay, this number, not whatever number this is. Okay, so this is a situation where you cannot just take the negative log of this number and call it a day for your POH. You have to multiply it by 2 because there's 2 hydroxide in the solution. Now, after we got to this point, let's go ahead and plug this into our POH. So POH is negative log of OH minus, negative log of 1.84. Let's do that into my calculator. Okay, negative 0.26. How many sigma do we have here? 3. 1, 2, 3. So we'll also have 3 here. So negative 0.265. That's only my POH though. I need to do my pH. So my pH is POH, or pH plus POH is 14. So pH is 14 minus POH, which is then 14 minus or negative 0.265. This would then lead me to this answer. Make sure to put in a negative in your calculator, like so. And then you should have 14.265. Because this is ends in the thousandth place, so your final answer should also end in the thousandth place. And that's my final answer. Okay, now this question just asks you for the pH and the POH of a certain molarity of this sodium hydroxide. There's not even 2 hydroxide there, so this one's actually pretty simple. Just make sure to do this one, just like how we've done all the other ones before. Number 13 asks you to calculate the concentration of hydroxide for a solution of sodium hydroxide with a pH of 10.42. Now, this question is similar to number 7 here. Well, not number 7, sorry, number 5 here. Except for this one, because they give the pH for a base, we need to do something extra. So let's go ahead and first find the POH, because using the POH we can find the concentration of hydroxide, right? Because POH is equal to the negative log of the hydroxide concentration. So let's go ahead and find POH. I know that pH plus POH is 14. So then POH is 14 minus the pH, which is 10.42. minus 10.42, 3.58. It looks like the sig fig works out as well. Okay, that's the POH. Now we can find the concentration of OH minus. Okay, so we 10 to the negative POH. We just found POH to be 3.58. And when you punch that into the calculator, you should get 2.63 times 10 to the negative 4 molarity with the correct amount of sig fig. Now, the question doesn't ask you for the concentration of hydroxide, but it asks you for the concentration of sodium hydroxide. You would still have the same answer. You just got to write one more time saying that, oh, okay, the concentration of sodium hydroxide is also this number. Because, remember, for strong bases, the concentration of the base is equal to the concentration of the hydroxide ion. So if you have the hydroxide ion, you have the concentration of the base. Alright, that concludes this video on the video answer key for this worksheet. Thank you guys for your attention. I will see you in class. Bye-bye.